This is AP Calculus AB. This is a quiz we had on 10/15 of this month, this year. And this is the 5 problems. For problems 1 and 2, apply the mean value theorem on f of x over the interval indicated. Find each value of c that satisfies the mean value theorem. So problem 1, f of x equals x cubed minus x squared minus 2x on the interval -1 to 1. So for that, we're going to apply the mean value theorem, we're going to need to have an a and a b. We're going to let -1 equal a and 1 equal b. And so to apply the mean value theorem, we need to find the average rate of change over this interval from x equals -1 to x equals 1. And for that, we're going to use the equation for average rate of change, which is f of b minus f of a over b minus a. So we'll say b is 1, so f of 1, we plug in 1 to this function here, so we get 1 cubed minus 1 squared minus 2 times 1. So that's going to be 1 minus 1 minus 2. That's going to be -2. So f of b is -2. F of -1, which is f of a, is going to be -1 cubed minus -1 squared minus 2 times -1. And that's going to be -1 cubed is going to be -1 minus 1, -1 squared is 1, so minus 1. So we have -1 minus 1, and then minus 2 times -1. So that's going to be -2 times -1 is plus 2. So we're going to have f of b is going to be, f of a is going to be 0. So in this case, a rock is going to be equal to f of b, which is -2, minus f of a, which is 0, over b, which is 1, minus a, which is minus -1. So we're going to get -2 over 2, which equals -1. So that's going to be our average rate of change. And so to satisfy the mean value theorem, there has to be a value. So we look at the function continuous over the interval from -1 to 1, yes, and differentiable, yes. Polynomial function will be both continuous and differentiable. So we're going to take the first derivative of this. So we say f prime of x equals 3x squared minus 2x minus 2. Okay, so, and for that, we're going to set our first derivative equal to our average rate of change. So we're going to have -1 is equal to 3x squared minus 2x minus 2. And solving this equation, if we solve for 0 on one side, we add -1 to both sides of the equation, we get 0 equals 3x squared minus 2x, and -2 plus 1 is going to be -1. And we can factor, I hope, this 3x squared minus 2x minus 1 to become 3x times x is 3x squared. And we're going to have -1 plus 1. We're going to have minus 2x. So we're going to have minus here, -1, because that would give us -3x, and then plus 1. So these will be our factors, which when we multiply these two linear binomial factors together, we're going to get this 3x squared minus 2x minus 1. So therefore, I'm going to come up here on the left. We're going to have 3x plus 1 is equal to 0. And solving for x, if we subtract 1, we're going to have 3x equals -1. So x is equal to -1/3. And it says c that's satisfied, and this is going to be on the interval indicated. So this would be x equals -1/3, one of our values of c that satisfies the mean value theorem. Next, we take this x minus 1, x minus 1 equals 0. And so we add 1, so x equals 1. Now, does this value satisfy the mean value theorem, x equals 1? Well, unfortunately, it does not, because the mean value theorem is that if we have this on the closed interval of negative 1 to 1, there will be a value on the open interval. So we're interested in an open interval between greater than negative 1, less than 1. And so this x equals 1 does not qualify because it's right on the edge. So we'll just stick with x equals negative 1/3. That is value C that satisfies the mean value theorem on this interval. Now, if we'd been between negative 1 and 2, well, then we would have, but that would have changed the average rate of change too. So we kind of would have changed everything. Okay, problem 2, f of x equals square root of x minus 3 on the interval of 3 to 7. And so same thing as above, we need we need our average rate of change, f of b minus f of a over b minus a. So we're going to find find f of b, and we're going to let a equal 3 and b equal 7. So f of b is equal to, we have square root of 7 minus 3, which equals square root of 4, which equals 2. So that's going to be our f of b. And our f of a is going to be f of what was it, 3? So we're going to get square root of 3 minus 3, and 3 minus 3 is 0, so we're going to have 0. So that's going to be our f of a. So our average rate of change is going to be equal to f of b, which is 2, minus f of a, which is 0, over b minus a, which is going to be 7 minus 3. So we're going to get 2 over 4, which simplifies to 1/2. So now we're going to take this function, f of x equals square root of quantity x minus 3, and we're going to rewrite this as f of x, pre-calculus rewrite, f of x equals x minus 3 to the power of 1/2. And f prime of x is equal to 1/2 times the x minus 3 to the power of negative 1/2, and that times the derivative of the inside. Well, the derivative of the quantity x minus 3 is just going to be 1. So we're going to rewrite f prime of x as 1 over 2 square root of x minus 3. And to apply the mean value theorem, to find which value applies, we set this 1 over 2 quantity square root of x minus 3 equal to 1/2. And for that, we're going to have 2 equals 2 square root of x minus 3, and dividing by 2, which works to the right, we're going to get 1 equals square root of quantity x minus 3. And squaring both sides of this equation, we're going to get 1 squared on the left, which is 1, equals just x minus 3. And adding 4 to both sides, we get a value of x equals 4. So x equals 4 is the value C that satisfies the conclusion of the mean value theorem, that there is a point on the curve where the tangent is equal, the instantaneous rate of change is equal to the average rate of change over that interval. The next problem 3, a marathoner ran the 26.2-mile New York Marathon in a time of 2 hours and 12 minutes. Show that at least twice the marathoner was running at exactly 11 miles per hour. Well, for that, the thing kind of makes sense without doing hardly anything. But what we have to do for this one is use a combination of the mean value theorem and the intermediate value theorem. And to do that, to demonstrate what that's going to effectively accomplish, I'm going to draw a little graph here on the right where we're going to take the time and we're covering a distance of positions. So we're going to say 26.2 miles over a time of 2 hours and 12 minutes. So start at time 0, position 0, and 2 hours and 12 minutes is going to be equal to 12 minutes is 1/5 of an hour, and 1/5 is 0.2. So we're going to cover this distance in 2.2 hours. So this is hours over here on the x-axis and miles on the y-axis. And so over that distance, we cover, over 2.2 hours, we're going to be covering 26.2 miles. So we can represent our average rate of change over that distance. It's going to be the slope of the line from the origin. So I'm going to just write here, slope of this line equals average rate of change. Now, what the mean value theorem tells us is that as the runner runs, let's say the runner starts out kind of fast and gradually slows up, but is still getting position and makes a path kind of like this, a path over time, position over time. And so there's going to be a point someplace. That's what the mean value theorem tells us, where the slope, we'll say it's right here. At this time, this slope, slope of this line, this tangent line, which I'm drawing in red, is going to be equal to the slope of the average rate of change. So slope of this one here is going to be equal to, I'm going to put I ROC, representing instantaneous rate of change. And so we would write our conclusion, we'd say, according to the mean value theorem, oh, we haven't made that calculation yet. We're going to take our average rate of change is going to be f of b minus f of a, which is 26.2 over 0. So I'll write this like average rate of change equals 26.2 over 2.2 hours. So I think it's going to be 11.909, I think that's what it is, miles per hour. Okay. So that's our average rate of change. So according to the mean value theorem, there must be at least one time that the runner was going at exactly exactly 11.909 miles per hour, put mph. Okay, so that's for the mean value theorem, because that 11.909 is the average rate of change, and so we know at least once that runner had to be traveling at exactly 11.909 miles per hour. Next, after we've done this, we have I'm going to make another graph over here to the lower left, and that's going to be velocity, not distance over time, but velocity, or speed. Let's put it this way, speed over time. So we still have the 2.2 hours, and we have speed of I'll put speed over here. And this one right here, I'm going to make a horizontal line. It's going to represent 11.909 mph. And so, presuming that the runner starts at rest, the speed will be 0 at the start of the race at time equals 0, and then we'll finish at the time equals 0. Now, I'm going to go ahead and draw another horizontal dotted line here that represents 11 miles per hour. And we know, according to the mean value theorem, that the runner has to go exactly 11.909 miles per hour at least once. So the runner has to reach this speed up here where I'm drawing this red dot. And so to go from time equals 0, I mean, it's from a start, a still start, the runner's going to have to come up to 11.909 miles per hour. And what he's going to have to do, he's going to have to go through and touch 11 miles per hour at least once. And then we'll have to come down after achieving that rate, come down before stopping sometime. To get to stop, he's going to have to cross through 11 miles per hour again. So to articulate this, we say according to the IVT, since the runner started and finished at rest and ran at a rate of 11.909 miles per hour at least once, according to okay, so according to IVT, the runner had to go exactly 11 miles per hour at least twice. So that's kind of involved, but that's the fully articulated how to answer problem 3. 4. What is the equation of the line that is tangent to the function or the graph of the function g of x equals 9 minus x squared where x equals -1? Well, for that, first of all, we need to find that point. To find the equation, we need to have a point. And to find a point, we need an x value, which we're given of -1, and a y value, we're going to say g of -1 equals square root of 9 minus -1 squared, and 9 minus -1 squared is going to be square root of 8. So our y-coordinate here is going to be square root of 8. Next, We're going to try to find the tangent line, so let's find g prime of x, but before we find g prime of x, we're going to rewrite g of x as 29 minus x squared to the 1/2 power. So g prime of x is going to be equal to 1/2 times 29 minus x squared, and then 1/2 minus 1 is going to be to the negative 1/2 power times the derivative of the inside. What's the derivative of this 9 minus x squared? Well, that's going to be negative 2x. And so rewriting this, we're going to have g of x equals, we're going to have negative 2x over 2 is going to simplify to negative x, and then this 9 minus x squared to the negative 1/2 power is going to be the square root of 9 minus x squared. So now we're going to need to plug in negative 1. So we're going to have g prime of negative 1 is going to be equal to, in the numerator, negative 1 over square root of 9 minus negative 1 squared. And so that's going to be in the numerator 1, and the denominator we're going to have the square root of 29 minus negative 1 squared is going to be 1 over square root of 8. And so that's going to be m sub t, so that's going to be our slope. It's going to be 1 over square root of 8. So the equation of our line is going to be y minus y1, which is going to be y minus square root of 8, is going to be equal to our slope, and our slope is 1 over square root of 8 times x minus negative 1, so that's going to be x plus 1. So that's going to be the equation of our tangent line at this point. Next, problem 5. What is the integral with limits 0 to 4 of 2x dx? What I'm going to do is rewrite this integral as, we can take this 2 outside the integral, so we're going to have 2 times the integral from 0 to 4 of x dx. And for what we've done in this class so far, if we graph this x dx, we can evaluate that function, what is under the curve or shape from 0 to 4. And so the y equals x looks like this, a diagonal line. That's going to be y equals x. And from 0 to 4, 1, 2, 3, 4, we get this area here. And this is a triangle with a base of 4 and a height of 4. And then we have, I'm going to shade in inside that triangle. And so the area of this triangle is going to be area equals 1/2 base, which is 4, times 4, which is going to be 1/2 of 16, which is 8. Well, so what we're going to have, that's the integral from 0 to 4. And so we're going to have 2 times 8, which equals 16. So 16 is our answer to problem number 5. Anyway, good luck on these problems. You're probably going to see a lot more like them. And thanks for viewing.